All right, so today I'm going to look at solving quadratic equations, but in this video I'm only going to look at solving them when they're in vertex form. So just a reminder of what vertex form looks like, right? A x minus h squared plus k, right? The idea of vertex form is that you can look at it, identify the vertex, of course, hence vertex form, right? If I wanted to graph this thing, right, we would just shift it right or left, shift it up or down, stretch or compress this thing vertically, reflect it over the x-axis, right, things of that nature. Now, to make sure we get a sense of the key component of how we're going to solve this, I'm going to start off with a nice, easy, basic one, right? The lowest form of vertex form would just be a regular old x squared. No shifting, no stretching or compressing, no reflecting or anything like that, right? Just a plain old x squared. And this is going to be good because if we wanted to just imagine values that would make this work or plug some numbers in, we know that we want a number squared to give us a value of 4 out. So we know, all right, well, if I plug in 2, 2 squared, right? 2 squared is equal to 4, right? That works, right? Or if I plug in -2, then what? -2 squared is also 4. So that also works. So 2 and -2 would both be solutions to this equation, right? But we're trying to not just guess numbers. So let's work through the process here to try to justify how we'll know that there's going to be 2 answers here. So let me just jot it down one more time, right? So I'm going to try to get you thinking about how to approach these problems. All right? I mean, I know we're only looking at them in vertex form now, but as we expand this out to different forms of quadratics, it'll be useful to look at the equation and try to identify, by what we have, what would be a useful set of steps to get x alone. So what I'm going to try to say each time is to look at how many x's we have, right? Physical letters, right? So in our equation, we only have one physical x, so we ought to be able to get this guy alone by just removing any operation that's on him, right? And in this case, basic form, we got a square. We know that a square root would cancel a square, right? So in an equation, we know that if we want to do something to the equation, like square rooting it, we have to do it to both sides. So in this case, if I'm going to square root the left side, I have to square root the right side. I know that the square and the square root will cancel, so I'm left with just an x. And then the square root of 4, anytime I use a square to remove, use a square root to remove a square, I'm going to add in a plus or minus on this other side. So this is going to compensate for kind of what we explored here, which is that a positive or negative version of that value could give us the result that we're looking for. Now, if this root reduces, because we know that square root of 4 is 2, then we can say that x is equal to plus or minus 2. And this is just shorthand for saying x is equal to 2 and x is equal to -2. So we have 2 answers as we anticipated. So using a root to remove a square can get rid of the exponent, but when we apply it to the other side, we need to put this plus or minus to compensate for the fact that there's 2 ways to make that value. So this is going to be the important step here that a lot of people are going to forget when we do this process. Let's try another one. So again, I'm looking to solve for x. I'm going to identify how many x's I have. This is going to help me generate a process or a plan to get that x by himself, right? I only see one x, right? Ignore the idea that x squared is technically 2 x's. I'm looking at physical letters, right? I see one physical x. That means that I should be able to get him alone and to x equals, right, which is our goal here, by just peeling away any operation that's on him, right? Now, At face value, a lot of people will say, well, I know that a square root cancels a square, so couldn't I just square root to get rid of the square first? Now remember, in terms of the equation, right, whatever we do to one side of the equation, we must do to the other. So if I was going to apply a square root, I would have to do the entire thing, right, because I'd have to do the whole side over here and this whole side. Now, this is manageable, which is fine. It's this part that throws a lot of people off, right? Because in this case, we might say, well, if I square root everything, couldn't I just square root both pieces like this? And so essentially just square root everything that I see, right? And then you can say, ooh, look, the squares cancel, and we don't have a square anymore, right? But the problem is that, like, if I had two terms with an exponent, that am I allowed to distribute the exponent to both pieces, right? And the answer is no, because this is just shorthand for whatever the base is times itself twice. So this is really like x plus y if I have two terms. Like this one, I have two terms, right? So whatever these two terms are, there's two of these. Right? That's what this exponent means. So just like I can't distribute the exponent to the two terms, since a root is an exponent, I can't distribute him to both of these either. This is not good. Right? So in order for the root to actually get rid of the square, it needs to be the only thing on that side. Right? So let me just rewrite it again. Clean this up a little bit. Right? So, again, going with the idea that we just want to get the x alone, I mean, this is the term with the x. So if I want him to be the only thing on this side, then this 5 needs to be moved to the other side so I can make that happen. Now, I can get rid of a negative 5 by adding 5, right? So we can add both sides, 5 to both sides. Nothing wrong with that. It's still going to be x squared on the left. 5 and 4 makes 9. Now that the square is only on the one side, right, there's not other things with here. If I square root the left side and the right side, since this is the only term on this side, it will actually cancel here, right? So we want to get the term with the x alone, or the term with the square alone, so that the root becomes a useful step, right? Now, I use the root to remove a square. So while it does cancel the square on the left, I do have to remember to put a plus or minus on that value on the right. Now, square root of 9 is 3. So x is equal to plus or minus 3, which is the same as saying x is equal to 3 or x is equal to negative 3. So we have two solutions. All right, so be careful with this. We can't just, we can put square roots on both sides, right? This is acceptable, but this is not. And this is the only time that this is going to be useful because it'll cancel that square, but we can't distribute exponents. And since a root is an exponent, we can't do this. That's not good, right? Isolate the term with the x. Once the root can be effective because it's the only thing on that side is being squared, then we can get rid of that square with a square root. All right? Let's look at another one. Okay. So again, just looking at this, how many x's I see? I see 1. So again, I'm just going to move everything to the other side by undoing the operations. If I want to underline the term that has the x, because I see 1x, this is the term that has the x. That means him. This is 8, he's got to go. So if I subtract the 8 from both sides, I'll at least get the term that has the x in it alone, right? And then what do we got? 23 minus 8 is, what is that, 15? Right? Now again, we know squares remove square roots, but if I wanted to square root this, I would have to square root the whole side, which includes that 3. Now the 3 is not being squared. Only the x is being squared. The 3 is being multiplied. So if I wanted to work through order of operations, right, if I divide, I can get rid of multiplication of 3, and then that'll leave me with the x squared so that a square root can be effective. So we can divide both sides by 3, right? That'll cancel this 3, get us back down to that x squared term. 15 divided by 3 is 5, right? Now, our goal is to get rid of the square. A square root can make that happen, right? The square and the square root cancel to leave us with just x. If I'm going to put a root on here, got to do a plus or minus, right? But does root 5 reduce? No, root 5 doesn't reduce. 5 is prime, so it doesn't break down into anything that could simplify. But then again, there's still 2 of them, the plus and the minus version. So if I wanted to, I could say x is equal to a positive version of root 5, or x is equal to the negative version of root 5. So again, both of these are solutions. Now this, in case you're thinking, oh, well, roots can't be negative, the value under the root can't be a negative, right? Then it would be like an imaginary number. So the root on the outside, that's fine. It's like 5 and negative 5, right? Root 5 is a real number, so the negative there, that's all right. Right? Let's try this one. So again, how many x's? I see 1, right? I want to get them alone. Now the x is inside the parentheses, which means in order to get to the x, I need to remove any operation on the parentheses, which in this case is a square. So this is all one big term. So if I want to use a square root to cancel a square, I have to do both sides. But since this is the only thing on this side, this is fine. This square and this square root are going to cancel, right? I'm still going to be left with what's underneath the root, which is an x plus 4. But that's okay. I can deal with that. I put that square root on, I can't forget the plus and minus, right? Now, I'm not done because I still want to get that x alone, right? So we have a couple of ways that we can think about this. We can say that there's 2 things that we have here. One is that the x plus 4 is equal to the positive version of this. Now, square root of 16, right? Square root of 16 is, I'm sorry, not square root of 4. Square root of 16 is 4. So the positive version of this would be 4, or x plus 4 can be equal to the negative version of this, which would be a negative 4. So if you want to think about it as 2 different equations, and then we can solve both equations independently, that's fine, right? Then we can say, I'm going to subtract the 4 from both sides, so x is equal to 4 minus 4 is 0. Again, subtract the 4 from both sides to get x by itself. Negative 4 and negative 4 is negative 8. So there's our 2 answers. Looking good, right? If we want, and you're all right with doing this, we can say that x plus 4, right, just to write it over here. Remember, this is, square root of 16 is 4, right? But it's still plus or minus. Okay? So if you want to just keep going to get the x by itself, we can just say, all right, we do want to subtract 4 from both sides. So x is equal to, now, we're not just going to say 4 minus 4 is 0 plus or minus 0, because we have a negative 4, right? That's this guy. And we have a plus or minus 4. That's this guy. And then we can, like, walk through the plus or minus, as I like to say. So we can say, all right, what are the x values? Negative 4 plus 4, which is 0, or negative 4 minus 4, which is negative 8, which is the same thing here. So if you want to keep the plus or minus, just remember that you can't just put these 2 numbers together and leave the plus or minus, because it's negative 4 plus the 4, negative 4 minus the 4. Right? So if you don't want to split it and solve them both down, that's fine. Right? You could kind of leave this consolidated term. But don't leave it like this. This isn't simplified, right? Because we can actually do 4 plus 4 and 4 minus 4, right? So this isn't simplified, right? All right, let's try another one. All right. So again, solving for x, how many x's do I see? I see 1. So again, we're just going to move everything to the other side, get that x by itself, right? The term with the x's here. So I'm going to want to move this 5 over, right? I can get rid of a negative 5 by adding to both sides, right? So this will leave this term over here. 5 and 1 makes 6, right? Now that the square is the only thing on this side, I know that a square root will be effective. So if I square root both sides, I'm just left with an x minus 2 over here. I put a square root on this side, gotta not forget plus or minus root 6. Now root 6 isn't a perfect root, nor does it simplify. So we're just going to leave it as root 6. But we're still trying to get x by itself, which is fine, right? So if we want to, again, if we want to split it and say x minus 2 is equal to the positive version, or x minus 2 is equal to the negative version, that's okay. And then we can just add 2 to both sides to say that, what? I'll just write it over here. X is equal to 2 plus the root 6, right? And if we add 2 to both sides, we can say x is equal to 2 minus the root 6. And there we go. The 6 doesn't reduce. I can't add roots and non-roots. That's as far as we're going here, right? Let's look at this one. So, again, I see 1x. Nothing wrong with that. This is the term with the x. I want him alone. So this 3, he's got to be moved to the other side. Get this term alone. So I can subtract 3 from both sides. Right, that's a 3. So 4x plus 9, still squared. 3 minus 3 is 0. Nothing wrong with that. Our focus is over here, right? Now, I could square root this whole side in this case because square root of 4 works out nicely. But I don't want to mix methods here. So I'm just going to try to get the square on its own. And since this is 4 times this value, I'm going to cancel multiplication with division. So if I divide both sides by 4, I'm going to get rid of this guy, which is nice. 0 divided by 4, just 0, right? Nothing wrong with that. Remember, our goal is over here. I could care less what's over here, right? We're just piling things up, and we're going to sort it out later. Now, since I can square root both sides, and he's the only thing on this side, we're just going to have the x plus 9 over here. Now, technically, this is plus or minus square root of 0, but square root of 0 is 0, and plus or minus 0 is just 0. So there's really only one way to look at this. X plus 9 has got to be equal to 0. So in this case, there's not going to be 2 answers because there's not 2 independent or unique values here, right? So if I just subtract 9 from both sides, x is going to be equal to 0 minus 9, which is negative 9, and that's it, right? The plus or minus kind of just gets absorbed into that 0, and we can get the x by itself, and there's just the one answer. Nothing wrong with that. So 0 is kind of a special case here if we get that, right? All right, let's take a look at one more. All right, so we got to make sure we're not doing anything incorrectly here. Okay, so I do see 1x. I should be able to get him alone by removing operations, right? Okay, now at first glance you might say, all right, well, 2 minus 5 is negative 3. I could just put those together. But keep in mind that this 5 is being multiplied by what's in the parentheses. So I can't do subtraction before multiplication, right? So I'm just going to leave those 2 separate. Remember, our goal is to get the term with the x. This is all one set of multiples. This is one term. I want to get him alone. So I do want to remove the 2. I can subtract it from both sides, right? So remember, I still got the negative with that 5, right? I still got the grouped parenthesis here, right? 38 Negative 38 minus 2 is negative 40, right? Okay. Again, I don't really want to deal with this multiplication before the root, so I'm just going to divide it away. If I divide it to one side, got to divide it to the other, right? That's going to give me that square on its own. I know the square root will do good things here. Negative divided by negative is a positive. 40 divided by 5 is 8, right? Now, the square root will reduce that square. That's good. That's just going to be x minus 3. Remember, plus or minus square root of 8, right? And then we can try to get this x by itself by just adding the 3. So really, this is x equals, now I can't add roots and non-roots together, right? Can't add roots and non-roots, so this is the positive 3 that I just moved over, plus or minus square root of 8. Now, I can't add the roots and non-roots, like I said, but if this root reduces, then I would want to do that. Now, while square root of 8 isn't a perfect square, right, we may be able to reduce it, right? If you need a little bit more help on reducing roots, you can go back and watch that video. But just going through this, I know that 8 is the same as square root of 4 times square root of 2, and square root of 4 is 2, right? So square root of 8 is really still the 3, still plus or minus, right, 2 root 2. So the plus or minus is on the root 8, and root 8 reduced down to 2 root 2. So the plus or minus should still be in front of that guy. No, I can't add the 3 and the 2 together, because again, this is multiplication. So I can't add any more together. I reduced the root. This is as far as we're going here. Right? This is as much as we can simplify it. Now we, if we wanted to, we could say, 3 plus 2 root 2, or 3 minus 2 root 2, right? It depends on, what you consider an acceptable answer there. All right?